We'll start in 1 minute. Today we'll continue with the Test 3 review over the Chapter 7 and Chapter 8 material. Remember that tomorrow is the test. You can join the test as early as 7:45, but it will be over by 9 o'clock. Okay, we got to this page. We're in sections 8.1 and 8.2, simplifying roots and radicals. So the first one, the square root of 121x to the 22nd. Both are perfect squares. The square root of 121 is 11, and the square root of x to the 22nd is x to the 11th. 22 divided by the index 2 is 11. Then the next one, the cubed root of negative 216 is negative 6, because the number negative 6 to the third is negative 216. And then the fifth root of 32 is 2, and then we can simplify further. Negative 6 plus 2 is negative 4. In part C, the fourth root of 81 is 3, because 3 to the fourth is 81, and the square root of 81 is 9, and then 3 minus 9 is equal to negative 6. Okay, the next one is also pretty simple. The square root of 144 times x to the 8th times y to the 12th. The square root of 144 is 12. The square root of x to the 8th is x to the 4th. And the square root of y to the 12th is y to the 6th. Okay, the next ones are only slightly more complicated. The square root of 125 times m to the 23rd. The largest factor of 125 that's a perfect square is 25, and the largest factor of m to the 23rd that is a perfect square is m to the 22nd. So rewrite this as the square root of 25m to the 22nd times the square root of 5m. And then we simplify the square root of 25m to the second to 5 times m to the 11th, and then 5 times m to the 11th times the square root of 5m. That is our simplified result. In the next example, the square root of a quotient, we can write that as the square root of the numerator, 98, square root of 98x to the 25th in the numerator, and in the denominator, the square root of 72y to the 18th. Okay, so in the numerator, the largest factor of 98, that is a perfect square, is 49. The largest factor of x to the 25th, that is a perfect square, is x to the 24th. In the denominator, the largest factor of 72, that's a perfect square, is 36. And y to the 18th is a perfect square. So we can rewrite this as the square root of 49x to the 24th times the square root of 2x. And in the denominator, we replace the square root of 72y to the 18th with the square root of 36y to the 18th times the square root of 2. Okay, I'll use a different color ink to distinguish between the expressions. So here in the numerator we have 7 times x to the 12th. I'm going to rewrite the square root of 2x as the square root of 2 times the square root of x, because in the denominator we have a square root of 2. But before that, the square root of 36 is 6. The square root of y to the 18th is y to the 9th, and then times the square root of 2. So we get a cancellation. The square root of 2 divided by the square root of 2 equals 1. And so our final answer is 7x to the 12th times the square root of x divided by 6 times y to the 9th. So we got the simplified answer. It turns out, though, that if we had reduced the fraction 98 over 32, or 98 over 72 first, in lower terms, 98 over 72 becomes 49 over 36. And then we could have avoided this square root of 2 over the square root of 2. But it still worked out okay. So on the next one, I learned from my misjudgment on part E. On this one, the cubed root of 16 m to the 24th divided by 250 n to the 30th. Note that 16 over 250 can be written in lower terms. They have a common factor of 2. So we can rewrite this as the cube root of 8 m to the 24th over 125 n to the 30th. And then in the numerator, the cubed root of 8m to the 24th divided by the cubed root of 125 n to the 30th. Well, everything's going to simplify nicely. The cubed root of 8 is 2. The cubed root of m to the 24th is m to the 24 divided by 3, or m to the 8th. And in the denominator, the cubed root of 125 is 5. And the cubed root of n to the 30th is n to the 30 divided by 3, or n to the 10th. So that is our simplified result. In the next section, we're simplifying rational exponents. So this first one, 64 to the 3/2. So that's supposed to be an exponent of 3/2. So think of this as 64 to the 1/2 and then to the 3rd. 64 to the 1/2 is the square root of 64, which is 8. And then we simplify 8 to the 3rd. So 8 times 8 is 64, and then 64 times 8 is 512. Okay, the next one, the number negative 64 in parentheses to the 2/3 power. The denominator of the exponent is 3. So first, find negative 64 to the 1/3, and then after that, raise it to the second power. The cubed root of negative 64 is negative 4. And then negative 4 to the second is positive 16. Okay, the next one, 6 to the 5/2 times 6 to the 1/2. Since we're multiplying two terms that have the same base, we can write the base raised to the sum of the exponents, 6 to the 5/2 plus 1/2. But 5/2 plus 1/2 is 6/2. 6/2 is 3, so we have 6 to the 3rd. And we can determine what that is. 6 times 6 times 6 is 216. Okay, the next one, 32 to the 3/5 divided by 16 to the 3/2. Well, in this one, we can simplify the numerator and then simplify the denominator, and then after that, simplify that result. So in the numerator, we can rewrite 32 to the 3/5 as 32 to the 1/5, and then to the 3rd. And in the denominator, 16 to the 3/2, we'll rewrite that as 16 to the 1/2, and then to the 3rd. In the numerator, 32 to the 1/5 is 2. The 5th root of 32 is 2, and then raise that to the 3rd power. In the denominator, 16 to the 1/2 is the square root of 16, or 4, and then 4 to the 3rd. And then in the numerator, 2 to the 3rd is 8. In the denominator, 4 to the 3rd is 64. And finally, 8 divided by 64 is 1/8. Okay, moving on to the next page. So section 8.4, add, subtract, and multiply radical expressions. Okay, here we have the square root of 72y to the 5th minus the square root of 50y to the 5th plus the square root of 98y to the 5th. So each of the square roots can be simplified. So we have to do the simplification of those first. So the square root of 72y to the 5th, we can rewrite this in our intermediate step as the square root of 36y to the 4th times the square root of 2y. And then the middle term, the square root of 50y to the 5th, rewrite that as the square root of 25y to the 4th times the square root of 2y. And then the square root of 98y to the 5th, rewrite that as the square root of 49y to the 4th times the square root of 2y. And then the square root of 36y to the 4th is 6 times y to the 2nd. And we multiply 6 times y to the 2nd times the square root of 2y. Then the middle term, the square root of 25y to the 4th is 5y to the 2nd, and then times the square root of 2y. And then the third term, the square root of 49y to the 2nd is 7y to the 2nd, which is multiplied by the square root of 2y. All of the terms are like terms. They have the same radical parts, the square root of 2y. They also have the same term y to the 2nd. The only things that are different are the coefficients, but that's to be expected. We can simplify by subtracting and adding. So if we just focus on the coefficients momentarily, 6 minus 5 is 1, and 1 plus 7 is 8. So the simplified answer is 8 times y to the second times the square root of 2y. Okay, the next one, part B, the fourth root of 48r to the 10th plus the fourth root of 243r to the 10th minus the fourth root of r to the 10th. The largest factor of 48 that is a perfect fourth power is 16, because 2 to the fourth is 16. And then 16 times 3 is 48. The largest factor of r to the 10th that is a perfect fourth power is r to the 8th, because the exponent 8 is a multiple of 4. So we rewrite the fourth root of 48r to the 10th as the fourth root of 16r to the 8th times the fourth root of 3r to the second. Okay, I can see that I'm going to run out of space, so well, maybe not. Let's look at the next term. The fourth root of 243r to the 10th. The largest factor of 243 that is a perfect fourth power is 81, because 3 to the fourth is 81. And then 81 times 3 is 243. And then once again, the largest factor of r to the 10th that is a perfect fourth power is r to the 8th. So we'll rewrite this as the fourth root of 81 r to the 8th times the fourth root of 3r to the second. And then we get the last term minus the fourth root of 3r to the 10th. The fourth root of 3 cannot be simplified further, but the largest factor of r to the 10th that's a perfect fourth power is r to the 8th. So we rewrite that as the fourth root of r to the 8th times the fourth root of 3r to the second. So there you can see it all, I think. Okay, in the next step, the fourth root of 16 is 2. The fourth root of r to the 8th is r to the second, because the exponent 8 divided by the index 4 is 2. And so the first term, 2r to the second times the third root, sorry, not the third root, the fourth root of 3r to the second. And then the next term, the fourth root of 81 is 3, and the fourth root of r to the 8th is r to the second. And then times the fourth root of 3r to the second. And then finally minus the fourth root of r to the 8th, which is r to the second multiplied by the fourth root of 3r to the second. The terms are like terms. They have the same fourth roots. Each one has a fourth root of 3r to the second. And they each have the same variable part on the outside of the radical, r to the second. So we can simplify by looking at the coefficients. 2 plus 3 is 5. 5 minus 1 is 4. So our simplified answer is 4r to the second times the fourth root of 3r to the second. In the next example, we're multiplying two square roots. So in generally speaking, my preference when I'm just multiplying two square roots is to write that as a square root of the product and then simplify the square root. So I'll do that here. The square root of 5x to the 13th y to the 5th times the square root of 80x to the 7th y to the 11th. So if I write it as a single square root, I'm going to multiply those two radicands. 5 times 80 is 400. X to the 13th times x to the 7th is x to the 20th. Here we're adding the exponents. 13 plus 7 is 20. And then y to the 5th times y to the 11th is y to the 16th. Here we're adding the exponents again. 5 plus 11 is 16. Each of the factors inside this square root are perfect squares. The square root of 400 is 20, because 20 to the second power is 400. The square root of x to the 20th is x to the 10th. The index of the square root is 2. The exponent 20 divided by the index 2 is 10. And then the square root of y to the 16th. So what's the square root of y to the 16th? Yeah, the square root of y to the 16th is y to the 8th. Because the exponent 16 divided by the index 2 is 8. So that is our simplified answer. Okay, the next one, we're multiplying two binomial-like expressions involving square roots. So we multiply those like we would multiply binomials. 6 times the square root of 5 times the square root of 5. And then plus 6 times the square root of 5 times 2 times the square root of 7. 6 times the square root of 5 times 2 times the square root of 7. And then minus the square root of 7 times the square root of 5. And then minus the square root of 7 times 2 times the square root of 7. Okay, 6 times the square root of 5 times the square root of 5 is 6 times the square root of 25, but the square root of 25 is 5. Or you can just remember that the square root of 5 times the square root of 5 is 5. So we have 6 times 5. Then the next term, we're adding 6 times the square root of 5 times 2 times the square root of 7. We multiply 6 times 2 to get 12. And the square root of 5 times the square root of 7 is the square root of 35, because 5 times 7 is 35. And then minus the square root of 7 times the square root of 5 is the square root of 7 times 5, or the square root of 35. And then we're subtracting the square root of 7 times 2 times the square root of 7, which is minus 2 times 7, because the square root of 7 times the square root of 7 is 7. Okay, simplify further. 6 times 5 is 30. The two middle terms are like radicals, so we can combine them. 12 times the square root of 35 minus the square root of 35 is equivalent to plus 11 times the square root of 35. And then minus 14, because 2 times 7 is 14. Then the final answer, 30 minus 14 is 16. So we have 16 plus 11 times the square root of 35. Okay, in section 8.5, this is the section on division with radicals. But in addition to just division is rationalizing the denominators, so rationalize denominators. So what that means is if you start out with a radical in a denominator, the goal is to find an equivalent expression that doesn't have a radical in the denominator. In part A, we have 7 divided by 5 plus the square root of 2. The square root of 2 in the denominator means that this number is irrational. It's not a rational number. So we want the denominator to be a rational number. So here we're going to multiply by 1 in the form of 5 minus the square root of 2 divided by 5 minus the square root of 2. So I determined what form 1 takes by what I saw in the denominator. We're starting out with a denominator of 5 plus the square root of 2. So the conjugate of 5 plus the square root of 2 is 5 minus the square root of 2. So we multiply by 1 in the form 5 minus the square root of 2 divided by 5 minus the square root of 2. This will enable us to end up with a rational number in the denominator. So in the numerator, 7 times the quantity 5 minus the square root of 2. 7 times 5 is 35, and then minus 7 times the square root of 2. In the denominator, 5 times 5 is 25. And then minus 5 times the square root of 2, and then plus 5 times the square root of 2, and finally minus the square root of 2 times the square root of 2, which is the square root of 4. So the numerator is simplified as it can be for now. This 35 minus 7 times the square root of 2. In the denominator, 25, the two middle terms add up to 0. And then simplify the square root of 4 to 2, so we have 25 minus 2. And then finally, 35 minus 7 times the square root of 2 divided by 23. So 23 is a rational number. That means we've succeeded in rationalizing the denominator. Okay, the next one, the square root of 13 divided by the square root of x minus the square root of 7. So we want to rationalize the denominator. So we're going to multiply by 1, this time in the form the square root of x plus the square root of 7 divided by the square root of x plus the square root of 7. So we chose 1 to include the conjugate of this denominator. Okay, so in the numerator, the square root of 13 times the quantity square root of x plus the square root of 7, we're going to get the square root of 13 times x, and then plus the square root of 13 times the square root of 7, which is the square root of 13 times 7. 13 times 7 is 91, so we get the square root of 91. And in the denominator, the square root of x times the square root of x is the square root of x squared, but the square root of x squared is x. And then we'll write the square root of x times the square root of 7 as the square root of 7x. Then we're going to subtract the square root of 7 times the square root of x, so minus the square root of 7x. And then minus the square root of 7 times the square root of 7, which is minus the square root of 49. But the square root of 49 is 7, so we have minus 7. Okay, so just one more step. In the numerator, we have the square root of 13x plus the square root of 91. In the denominator, we have just x minus 7, because in the previous step, plus the square root of 7x minus the square root of 7x combine to make 0. So now we have no more radicals in the denominator. Okay, part C, 7 divided by the fourth root of 5. So think of 5 as 5 to the first. So we ask, since we want to rationalize the denominator, we ask, what would I have to multiply by 5 to the first in order to get a perfect fourth power? Yeah, so I would have to multiply 5 times 5 to the third to get 5 to the fourth. Okay, so the form that one takes is I multiply by 1 in the form the fourth root of 5 to the third, which is, you can write it as 5 to the third or 125, divided by the fourth root of 125. So the numerator is 7 times the fourth root of 125. The denominator is the fourth root of 5 times 125, which is 625. But 625 is 5 to the fourth, and the fourth root of 5 to the fourth is 5. So our final simplified answer is 7 times the fourth root of 125 divided by 5. Okay, the next one, 5 divided by the cubed root of 121y, or the third root of 121y. So 121 is 11 to the second. So what would I have to multiply by 11 to the second to get a perfect third power? I would just have to multiply 11 to the second by 11 to the first to get 11 to the third. So the form that one takes this time, oh, I have to deal with y here too, but I'll just rewrite this. The 5 divided by the third root of 121y. What would I have to multiply by y to get a perfect third power? Y to the second. Y to the second times y is y to the third. So the form that one takes is going to be the third root of 11y to the second divided by the third root of 11y to the second. Okay, so the numerator is finished, 5 times the third root of 11y to the second. And in the denominator, the third root of 121 times the third root of 11, that's going to simplify to 11. And the third root of y times the third root of y to the second will simplify to y. So I left out some of the details, but if you put in more details, you'll still end up with 11y. Okay, the next one, simplify the square root of 7mn divided by the square root of 175 mn to the 7th. So on this one, notice that in the denominator, 175 is 7 times 25. So we can simplify first. Let's just think of the numerator as the square root of 7 times the square root of m times the square root of n. And in the denominator, the square root of 175, think of that as the square root of 7 times the square root of 25, because 7 times 25 is 175. And then we have the square root of m. Think of the square root of n to the 7th as the square root of n times the square root of n to the 6th. Okay, and we get a bunch of cancellations. The square root of 7 divided by the square root of 7 equals 1. The square root of m divided by the square root of m, that equals 1. The square root of n divided by the square root of n equals 1. And then we write down what we have left. Well, 1 is a factor of everything, so the numerator has a factor of 1. In the denominator, the square root of 25 is 5, and the square root of n to the 6th is n to the 3rd. So that is our simplified answer, 1 divided by 5 times n to the 3rd. Okay, the next page, solve the radical equations. Here we have the square root of 7x minus 10 equals 5. So we begin by squaring both sides. We want to solve for x, but x is inside a square root, so we square both sides. When we square the square root of 7x minus 10, we just get 7x minus 10. And 5 squared is 25. Then add 10 to both sides, 7x equals 35, and divide by 7, x equals 5. Okay, you can tell pretty much by looking that when you check this, replace x with 5. 7 times 5 is 35. 35 minus 10 is 25. And the positive square root of 25 equals 5. So that works out. The next one is a little more complicated. The square root of 3y minus 2 equals y minus 2. So we square both sides again. So the square root of 3y minus 2 squared. And square the right-hand side, y minus 2 squared. When we square the square root of 3y minus 2, we just get 3y minus 2. When we square y minus 2, that means y minus 2 times y minus 2, we get y to the 2nd minus 4y plus 4. We'll make the left-hand side 0 by subtracting 3y and adding 2 to both sides. So we get 0 equals y to the 2nd minus 7y plus 6. And this factors really nicely, y squared minus 7y plus 6. The two factors are y minus 6 and y minus 1. So this equation, this quadratic equation, has two solutions, y equals 6 and y equals 1. Okay, but let's test those. Test y equals 6. Replace every y in the original equation with 6. So we get the square root of 3 times 6 minus 2 is, and then we set that equal to 6 minus 2. The square root of 3x, or 3 times 6 minus 2, 3 times 6 is 18. 18 minus 2 is 16, and the positive square root of 16 equals 4 is true. So y equals 6 is a solution. And when we test y equals 1, replace y with 1, we get the square root of 3 times 1 minus 2. On the right-hand side, 1 minus 2. So the positive square root of 3 minus 2, or the positive square root of 1 equals negative 1. That's false. The left-hand side is a positive square root. So that means y equals 1 is not a solution. Okay, in the next example, the fourth root of 3r plus 4 equals 2. We want to solve for r, but r is inside a radical with index 4. Okay, so to get r out of the radical, we have to raise both sides of the equation to the exponent 4. So the fourth root of 3r plus 4 to the fourth equals 2 to the fourth. The fourth root of 3r plus 4 to the fourth power is just 3r plus 4. 2 to the fourth is 16. And then solve for r. Subtract 4 from both sides. 3r equals 12. Then divide both sides by 3, we get r equals 4. So you can tell by looking, replace r with 4. 3 times 4 is 12. 12 plus 4 is 16. And the positive fourth root of 16 equals 2 is true. So r equals 4 is a solution. Okay, the next example, 7 times the square root of x equals x plus 10. So for this one, just begin by squaring both sides. Square the quantity 7 times the square root of x on the left-hand side, and on the right-hand side, square the binomial x plus 10. When you square 7 times the square root of x, remember what that means. 7 times 7, maybe I should write it out. 7 times the square root of x times 7 times the square root of x. When you square x plus 10, that means x plus 10 times x plus 10. And then 7 times the square root of x times 7 times the square root of x. 7 times 7 is 49. The square root of x times the square root of x is the square root of x squared. And the square root of x squared is x. On the right-hand side, x squared plus 10x a second time, and then plus 100. Okay, so on the right-hand side, when we combine like terms, we'll get, in the middle term will become plus 20x. So we'll subtract 49x from both sides, and we'll get 0 equals x squared minus 29x plus 100. This factors pretty nicely. X squared minus 29x plus 100. One factor is x minus 25, and the other factor is x minus 4. This equation has two solutions, x equals 25 and x equals 4. So, but remember that we started with this equation with a radical in it. So we should check. When we check x equals 25, 7 times the square root of 25 equals 25 plus 10. The square root of 25 is 5, and 7 times 5 equals 35. That's true. So x equals 25 is a solution. Then check x equals 4. So 7 times the square root of 4, set that equal to 4 plus 10. Square root of 4 is 2, so 7 times 2 equals 14. That is also true. So x equals 4 is also a solution. Here, the last section that will be covered on test 3 is section 8.8 that involves square roots of negative numbers. So remember the definition of the imaginary unit. The square root of negative 1 equals I is just a definition used for convenience. Okay, so the square root of negative 36, think of that as the square root of 36 times the square root of negative 1. And then the square root of 36 is 6, and we replace the square root of negative 1 with I. So 6 times I, or 6I, is what we get when we simplify the square root of negative 36. Simplify the square root of negative 121. Think of that as the square root of positive 121 times the square root of negative 1. 121 is a perfect square. The square root of 121 is 11. And we replace the square root of negative 1 with I, so we get 11 times I for the simplified result. Okay, the next one, the square root of negative 75. We write that as the square root of 75 times the square root of negative 1. 75 is not a perfect square, but the largest factor of 75 that is a perfect square is 25. 25 times 3 is 75. So in our next step, we write the square root of 25 times the square root of 3, and then replace the square root of negative 1 with I. And then the last step, the square root of 25 is 5, so we get 5 times the square root of 3 times I. That is our simplified result. The square root of negative 32, rewrite that as the square root of 32 times the square root of negative 1. 32 is not a perfect square, but the largest factor of 32 that is a perfect square is 16. So rewrite the square root of 32 as the square root of 16 times the square root of 2. Replace the square root of negative 1 with I. And then our simplified answer is 4 times the square root of 2 times I. So the next one's more of the same. The square root of negative 145. Rewrite that as the square root of positive 45 times the square root of negative 1. The largest factor of 45 that's a perfect square is 9. 9 times 5 is 45. So we have the square root of 9 times the square root of 5, and then replace the square root of negative 1 with I. And then the square root of 9 is 3, so 3 times the square root of 5 times I is the simplified result. Okay, on the next one, the square root of negative 252, rewrite that as the square root of 252 times the square root of negative 1. Okay, the largest factor of 252 that's a perfect square is how much? So 36. 36 times 7 is 252. So we write this as the square root of 36 times the square root of 7 times I. And then the square root of 36 is 6. And there's a question on the YouTube. Yeah, you can rearrange the factors. You can put I before the square root of 7. Or you can put I to the right of the square root like we have been doing. Just make sure that you don't put I inside the square root. Okay, so we're out of time. We got through all of the problems on the review sheet. So tomorrow morning at about 7:45, you can start test 3 on Zoom. I'll send a Zoom link a little bit later today. But that is all for now.